Nice.
That's an Oscar winner for sure.
Doug, every time I, look inside the office there, I see really unique and cool things and stuff that makes you snap your head and you go, ooh, ah. Today, I think you may have taken it to a new level. That room looks like you are surrounded by some serious metal.
Yeah, serious metal and some serious horsepower. I guess accumulatively, there's a ton of horsepower sitting up front today.
Yeah, absolutely. So today we're talking about boost, and I mean, we've hinted on non-naturally aspirated things in the past, right? We've talked about blowers a little bit. We've talked a little bit about turbos. We've talked about nitrous. We've dabbled on all of that kind of stuff. But today on Engine Room TV, we want to go deeper into it. And obviously, you're the guy to talk to about all this stuff. That one that's right in front of you right there, that engine, I mean, that's a beautiful looking setup. You want to start with that one? Come and talk to us about what's going on right there in front of you.
So we got a whole plethora of different supercharged and turbocharged motors that are going through the facility at this given point in time. So what's actually sitting in front of us here is a 400, and I wanted to call it a 427. It's actually a competitor's long block, which is fine. We were contracted to do the fuel injection system and the entire front blower system. So I think it's a 438 cubic inch. They use a little bit longer stroke, but for all intents and purpose, F2 Pro charged their entire front accessory drive, of course, running a Holley EFI system. This one, you'll see we converted the intake manifold. It was a carbureted setup. So we go ahead and convert the manifold, put injector bungs in it to make it EFI for the guy. So that's what this one is. The one just a little ways over is our 427 boost ready, and it's featuring actually the same intake manifold, also been converted. Bit bigger throttle body on top, obviously that huge air hat you see, Pro Extreme from Extreme Velocity, and that one features the YSI blower from Vortex. So we've actually got another mate to this on the dyno we can go take a look at, and it's a 363 but sporting the entire same front drive. We spent a lot of time with Concept One on designing that front pulley kit to use in late model and early model Mustangs, and a boatload of other things, but it was proprietarily built for the YSI, so we had contracted them to do that for us.
Talk to me about pulleys, because guys are always talking about, oh, I've got this pulley, or I got to change the pulley and I can change the boost and all that stuff. Obviously there's, as in anything with an engine, right? There's kind of a sweet spot if you're looking for a particular level of power. What is it that the pulley does? What's actually going on in there?
Well, it's all about maximum blower speed. So you don't always have to put everything on kill mode, but there is a maximum suggested impeller speed. So inside of the blowers, this Pro Charger, I think this is a 5.1 step up ratio. I can't remember what the YSI is, but there's a gear set inside of here that steps up that ratio to spin the blower or the impeller at a certain speed. So maxed out, both of these actually share the same impeller speed at 65,000 RPM. So combination of your pulley stack and then the step up ratio. So what you'll kind of notice actually is pretty interesting is when you're looking at the Pro Charger setup, the crank pulley diameter versus the diameter of the blower pulley versus what we got going on the Vortex over here. And that's just because the step up ratio is obviously not as steep in this blower. So we have to put quite a bit smaller pulley on it to be able to get the speed up to 65 or 70,000 RPM.
Got it. So then you've talked to this a little bit in the past, but since we're talking, boost today, it's a good time to bring it back. The different types of superchargers. It looks like those two that you've got right there are, and I'm not the supercharger guy, those look to be pretty similar setups. Is that right?
Well, yeah, they're all going to be basically called a centrifugal supercharger. So whether it's, you got Torque Storm superchargers, we do a lot with them. Got ProCharger, Vortec. They're all great companies. They all produce great products. I kind of call it a side-mounted hair dryer. So it's really a turbocharger without the exhaust side. Instead of the exhaust accelerating the impeller, it's going to be on a pulley.
Sure. So
and driven off the crankshaft.
And that's a great way to talk about it, because it's essentially working like a belt driven turbocharger, whereas superchargers, and I'll use like a Hellcat, for instance, right? The gears spin together. You can explain it a lot better than I can.
Well, twin screw. So you've got like your old school roots blowers. You see us do those. We just recently did a pretty killer LS, got another one coming up. So the roots, like your BDS, your blower shop, I call them TBS, the blower shop superchargers. So those are screw type chargers that have two rotors inside, versus this is got a volute or a snail, as I call it, with an impeller inside of it. So much different. These are easier to turn. They don't cost you as much horsepower to turn them, and they're more efficient. They don't heat the air as bad. So ultimately, when we're looking to make big power on pump gas or even race gas and other fuels, really the belt-driven supercharger centrifugal like this is quite a bit more efficient than your Whipples and other things. But they all have their place as far as in the industry, that's for sure.
So you don't necessarily have a favorite. Is one necessarily better? It's just different.
Yeah. So I'm sure there's viral videos out there of like Whipples, Magnusons. They've got that really extreme whine, and it's those two rotors inside the blower. Some people just simply buy those because of the whine, right? They sound cool. But they still make killer power. Have to, hand it to Whipple. They've done a great job. So they went from a 2.9 liter to a 3 liter. I'm thinking, what? 0.1? 0.1 of a liter is nothing. But it loves RPM and blower speed, and it doesn't heat the air as bad. So they've done something in R&D to figure out the efficiency to really, really, bring it up in somewhat of the land of these centrifugals. So, I wouldn't choose one versus the other per se. It's all up in the customer's hands these days. I don't really have a favorite. Anything that's makes big power, whether it's supercharged, turbo, nitrous, I don't care. It's all fun.
It seems like the manufacturers, OEM stuff, whether it's, and I guess pretty much everybody, right? Whether it's Ford or Chevy or Dodge, they're all using twin screw from the factory. Is that right?
Yeah, probably a lot cheaper, easier to package, because you could think it's on top, keeps a low profile, whereas you start to see that these types of systems start to get hyped up. So packaging, and then the front end, you basically got your blower and then the pulley stack. You can put that offset wherever you want to work with the accessories. Most of your late model cars are very, very tight engine bays. So it's going to be a little bit harder to get, stuff like this, sitting in a, late model Corvette, Camaro, whatever. But they do, of course, ProCharger, Vortec, they all got kits for them. But I think the factory, just on a cost and packaging standpoint, is probably the reason they do it.
Yeah, no doubt about it. When we first started Engine Room TV, however many months ago, we talked a lot about the internals and the things that you were going to do to make sure that thing was going to live under those types of situations. What do you have to do for a supercharger?
Pretty similar. So it's always the foundation. Start with a good block. We use Dart, World Products, LSR. There's a handful of them out there. They're all great. And then the internals. So 4340 crank, H-beam rods, good pistons. So we use a handful of different manufacturers in our stage one. Look at Eagle, Scat, Liberty, K1 on your crank and rods. Generally going to be a DSS FX3 piston. So those parts are pretty common. What we would look at versus, say, a nitrous motor, normally we're going to pay more close attention to what kind of compression ratio. So if we're looking at pump gas, most of our boosted combinations, supercharged and turbo, are going to be a lower compression, somewhere in the 9, maybe 9.5. You will see those numbers a little higher in the 10 and a half range when guys start running either methanol or E85. So that's really the only thing that we look at slightly different is going to be compression ratio, depending on the fuel source and what they're doing with it. So that overall part's really the same. Cylinder heads, Inconel valves, all that's still going to be the same. Good head studs. So very, very similar. We've got different stages. So just like the nitrous motor we talked about, good for 1,000 to 1,200 horsepower. We hit our 1,000 target on that one. On the Ford specifically, there is some things we do. We rate our stage 1 up to about 800. We kind of cap it at 8. They'll certainly make or withstand 1,000 horsepower, but usually the head gasket's the hard thing to keep in it after a certain point. So that's kind of why we draw the line at 800 to 1,000, and we do an optional flame hoop to allow those components upwards in the 1,200 range. From there, we would do like a stage 2, get into billet cranks, billet rods, really still the same piston. So very, very similar, I guess, to answer that question.
So now we understand the differences between centrifugal superchargers and twin screw superchargers, plus what we're looking at for the engine itself to handle all that boost. Now in part 2, Doug's actually going to show us the parts that he uses to make big horsepower reliably. And that includes something called a flame hoop. It's a trick from the top fuel dragster world, and he can use it on your boosted engine too.
You've got this interlock where there's enough as the head's moving, it keeps the cylinder pressure where it's supposed to be in the motor.
Once it's all together, we get to go to the dyno and see how it works and what kind of power we can make. That's next time on Engine Room TV, powered by Prestige Motorsports. I'm John Hammer, and I'll see you then.